Hello and welcome to a new video here on my channel, here at commaik. Today I would like to once again discuss the planning of a lawn irrigation systems are the focus. It addresses the questions. How much water does such a system need to function? How much pressure do I need at the water connection? How many sprinklers can be connected to one circuit? What can I do if my water connection is not sufficient? If you want to know the answers to these questions and how I did it myself, calculated and implemented carefully, thoroughly and meticulously, then stay tuned. It's about to start. Make sure to stay tuned because it is definitely about to start very soon. I installed a lawn irrigation system in my lawn over 2 years ago. My system consists of 6 irrigation circuits with 3 Hunter i20 lawn sprinklers each. The distribution among the circuits is done through 2 valve boxes. One box is equipped with Hunter, the other box with Rainbird. The automatic control is handled by the irrigation computer. In my case, a Hunter X-Core 801. With this controller, I could manage a maximum of 8 control circuits in parallel. Regarding the individual components, planning, I have filmed many videos on the installation of the Hunter lawn irrigation system. The appropriate playlist, as well as an initial overview of what materials you will need. You can find it in the video description, since I am not the only one who started from scratch with the construction of a lawn irrigation system. I often get questions. Is my water connection sufficient? How many sprinklers can I install? And alternatives. I will address these questions here, using my own system as an example. Please note that I operate this system privately and my tips are not legally binding. Unsure or considering larger and more complex systems should most definitely rely on a professional company. To understand the principle and the functioning of a lawn irrigation system, to understand better, I would like to start with the basics. I currently get my water from my house connection. Later, I would like to realize the whole thing through a cistern. Some of you, in that case, you need to adjust your calculations to the pump performance. Furthermore, I will address the flow resistances that arise from the water pipes. Not taken into account in my calculations, you should be aware that the longer the pipe runs are, and the smaller the cross-section of the pipes, the more likely you need to round off or accept losses. Now let's move on to the planning. First, you should familiarize yourselves with, arm yourself with paper, a measuring tape and a pen. You should measure the area to be irrigated. Have measured, knowing where you want to place the sprinklers. I have already created a video on how to easily calculate everything online. You can find the video in the playlist below in the description. You will also need the throw distance of the individual sprinklers. That means where you want to place the sprinklers later. Measure. Some need only 4 meters while others need 10 meters. This has a decisive influence on which sprinkler you will need to use later. The pressure and the water volume must be suitable to adequately supply all the lawn sprinklers. If it is not sufficient, you may need an additional irrigation circuit, or your lawn will not be fully and comprehensively irrigated in a proper manner. If it is not enough, you will need an additional irrigation circuit. Your lawn will then be irrigated in succession by several circuits. This will take a bit longer overall, but leads ultimately to the same result. Alternatively, you can use a different sprinkler, a sprinkler that uses less water, but even this one would have to run longer. The goal is ultimately to irrigate the entire lawn area uniformly with the same amount of water. For this reason, different sprinklers should not be combined in one circuit. Because if one sprinkler irrigates 10 liters per hour, while the other only irrigates 2 liters, it is completely clear that one part of the lawn is always drier than the other. Each of your lawn sprinklers will later be connected to a water pipe. I personally use 25 PE pipe. My water connection only has 26, even when using a 32 pipe. I would gain no advantage. Basically, my recommendation is, the larger the cross-section, the better. If your water connection can provide more, then size it more generously from the start. The water pipe should be laid out so that the sprinklers are connected in parallel. So not one after the other in a row, but side by side. If that is not possible, there is a risk that at the first sprinkler, enough water arrives, but at the last one there is far too little, or even none at all. Sometimes, the position of the pipes already determines the number of sprinklers. In my opinion, it doesn't make sense to lay the pipe in one direction of the garden first, to connect 2 sprinklers there, and then from there, to walk another 50 meters in the opposite direction. just because this line could still accommodate another lawn sprinkler. In this case, you set up 2 circuits from the beginning. One goes to the left towards the 2 sprinklers, and one's to the right to the other sprinkler. But now let's get to the question of how to calculate the whole thing. It's completely simple. You read from a table provided by the manufacturer how much water the lawn sprinkler requires. In this context, the water pressure and the throw distance are important. The measured water volume in liters, either per minute or per hour. Add up the total for the sprinklers, then check if your water connection can provide this amount. In case of doubt, you should always round down and opt for a second water circuit. In general, the water flow at the lawn sprinklers can always be reduced, but do not increase. But how can I now determine these key figures? To determine the water flow of my water connection, I need a 10-liter bucket and a stopwatch. You position the bucket at the transfer point. In my case, that is the faucet. For you, it may be the pump outlet. Then it is measured how long it takes for the 10-liter bucket to fill up. Here you see, as you can clearly observe, my measurement setup, a bucket with a scale up to 10. I painted that again here at the back. Theoretically, I could simply read this off the water meter. But not everyone has a water meter. That's why I'm doing it with a bucket now. Here's the stopwatch. Now let's just take a look. How long it takes to fill these approximately 10 liters. On your marks, get set and ready. Go immediately. As you can hopefully see now, 17 seconds, just under 18 seconds. I currently need to fill a 10-liter bucket with water. You simply calculate the flow rate as follows. You simply take the 10 liters and divide it by your seconds. In my case, I calculate with 18. The whole thing is multiplied by 60. This results in the water flow per minute. In my case, that is 33 liters. If I multiply the whole thing by 60 again, I then arrive at 2000 liters per hour. Everything is always rounded down to the worst. If your water flow is rather limited, and if you have a bucket with an accurate scale, you can also measure how much water flows into the bucket in 10 seconds. You multiply the result by 6, and you have the performance of the minute. Unfortunately, you can measure the water pressure, not so easy to calculate. Here it is advisable to attach a manometer to the connecting the faucet. If you don't have one, you will find the water pressure perhaps at your home fixture or at your water filter. In case of emergency, you can ask a neighbor as long as the water pipes are approximately identical. Pump users look at the pump's datasheet or measure at the pump's outlet. Also measure the pressure with a manometer. I have a pressure of 4.0 to 4.5 bar. That depends very much on the time of day for me, how much water is consumed in my house, but also in the street and in the neighborhood. For my calculations, I assume a pressure of 4 bar. Now you have determined all the necessary and important key figures, and the calculation can proceed. You can either use the paper catalog for this, or you can do it like I do and just go online. Let's get started on the PC and dive into the details of our exciting journey. As you can see, I have started my browser and prepared various tabs. Here is the planning guide for systems in private green spaces. I find the guide from Hunter to be absolutely very well done. The PDF consists of 31 pages and shows how an irrigation system should be installed. It clearly shows how one should proceed. Page 5 further discusses the extent to which the pipe diameters of the water pipes have a significant impact on the performance and efficiency of the system. What also comes out of the sprinklers. I completely overlooked that in this video. You should really definitely read this. You can find the additional links and information below in the description. I jump straight to the next tab, into the catalog. I have also included this link below. Please find the link, which is conveniently linked in the description. Here you see the gear-driven sprinklers. I use the Hunter i20. This one here. The Hunter i20 has a throw range of just under 5 meters up to 14 meters. In this context, I must say, for what I have used so far, I may have gone a bit over the target, but it works. I then had to somewhat rely and also on the black short-range nozzles. The nozzles, which means that a variety of different options are available to choose from, are freely selectable in the Hunter i20. This means you can simply change this red nozzle, here as an example with the PGJ. There are various different variants that can be purchased individually. The nozzles are also included in the starter kit. I will now jump directly to the Hunter i20. You see the product sheet here. The Hunter i20 is a pop-up sprinkler. This means that if there is no pressure and it is not running, you won't see anything at all. Here my mouse is the grass sod. The sprinkler is buried. When the water comes, meaning the system is pressurized, in other words, the system is under pressure. This area here rises by approximately around 10 centimeters, like 10 centimeters is the rise height. That is how high the i20 rises and sprays the lawn. I am absolutely and very satisfied. I scroll to the next page to show the individual nozzles that are available. By default, there are the blue and grey nozzles. As far as I know, they are included. The i20 was included with the purchase. The green and black nozzles must be purchased separately. I had to search for a long time before I finally found it in an online shop. I typically use the grey nozzles on the areas that are usually larger, especially when I am working on them. These systems allow for efficiently watering and maintaining the green lawn, with a throwing distance of approximately 7 meters to 11 meters, ranging from a distance of between 7 and 11 meters. I have carefully installed the black nozzles on my small lawns, and efficiently. These black nozzles can then irrigate just under 5 meters, approximately up to 7 meters or so in length. For some, additional data is still relevant. Here, for example, LA, that means low angle. This means nothing other than that the nozzle is designed in such a way that the water jet exits relatively flat, namely at 13 degrees instead of the usual 25 degrees. What you see here in blue is the nozzle component, which can be interchanged. Then there is still a number here at the front. This is ultimately nothing more than the size of the opening from which the water comes out. The larger this number is, the larger the opening is, and the more water comes from the sprinkler. You can see this in this table. Here it says liters per minute. The 1.5 nozzle at 1.7 bar pressure and a maximum throw distance of 8.8 meters needs approximately 4.5 liters of oxygen per minute. If I now go from 1.5 to 3.0, which is double, then I am already at approximately 8.4 liters per minute, the amount that is applied or needed. The precipitation rate increases from 7 to 9 mm per hour. That's enough about the nozzles. Now it's time to look at how many sprinklers can I really connect to my faucet. In the attachment I showed you earlier, I have installed the black nozzles, the short sprayers. I'll scroll down directly and quickly to the section where the black nozzles are presented. You can now see the pressure in bar in the first column, and here is the pressure in kilopascals in the second column. Then follows the throwing distance as measured in meters. The water flow, measured in cubic meters per hour or liters per minute. Finally, the precipitation rate as measured in millimeters per hour. Regarding the precipitation rate, it should be mentioned at this point. The higher this number is, the more water is applied to the area. This means a very significant difference in the time you need. If you have a rather clay soil like I do, then it shouldn't be too much. Otherwise the water cannot be absorbed by the soil at all. Puddles would likely be produced. If I now take the 3.0 nozzle in the extreme case, then I could do this here. Apply 25 millimeters or 25 liters square meter hour. That's quite a lot of amount to consider and reflect upon. The ground would drown. That would be way too much water at once. That's why I use both the grey nozzles and the black nozzles. The 2.0 or the 2.5. The 2.5 nozzle is available for the grey nozzles, not for the black nozzles. I scroll to the black 2.0 nozzle. If you use smaller nozzles, you will need to run the irrigation system for a longer time to have the same yield, that is, the amount of water. In my opinion, the rule of thumb is, the more clay the soil is, the smaller this number should be. If you have a rather sandy soil, then the number should be rather large. The water can seep in relatively well there. I am now scrolling back to the nozzle 2.0 in black. This is a short sprinkler nozzle. My system has 4 bar. That's it. What I assumed earlier. So between 4.0 and 4.5 bar, I'll start with the smaller value. My water connection provides 4.0 bar. My throwing distance is approximately 4 to 5 meters. 5.5 meters would be the maximum possible. I can easily adjust the throw distances on the Hunter i20, but to differentiate or throttle a little, I already have a few options for that. It is crucial to understand that, as shown in this table, the Hunter i20 model equipped with the 2.0 nozzle requires approximately 8.2 liters of water per minute. That's quite a lot already, and this would mean that approximately 2 sprinklers each require 16.4 liters, while 3 sprinklers require 24.6 liters. You simply put, look at how high the flow rate is in liters per minute. Then you check how many sprinklers you have planned for this circuit in total, or how much the online tool calculated for you, which I introduced to you in another video. This way, you will arrive at a total amount. In my case, that is 24.6 liters for 3 sprinklers with the nozzle 2.0. My water connection currently provides approximately 33 liters, and I need 24.6 liters. I could now install an additional 4th sprinkler, and would land just on the edge with just under approximately 33 liters or so, or thereabouts. That actually worked indeed, but when the pressure decreases significantly, because a large water consumer opens in the house, I noticed that as well. Therefore, my recommendations. When in doubt, it's better to round down. You should definitely also round off for the reason that the longer your pipe runs are, the higher the resistance will be. The water arrives after 200 meters. The pipe path then comes out a bit slower or with less pressure. This is, of course, also a reason why the number of sprinklers should be rounded. So, I would have more than the amount of resources, opportunities, or whatever is necessary to achieve the desired outcome. You can accommodate the current 3 sprinklers. But one area of the lawn is located rather in the shade, the other one clearly more in the sun, and because of that, my water pressure. I have fluctuated quite a bit, but I have come to a decision and said, okay, perhaps, maybe a water circuit to the east, possibly. I pull it to the left, and then the 3 sprinklers will be attached. Then, approximately 24 liters are needed in total. A second circle on the upper lawn area then goes westward, to the right side. There, 3 sprinklers get 24 liters per minute. This way, I have enough water capacity to operate the sprinklers. At the same time, I also have the opportunity to say, the shaded area is not watered for just as long, and in the sunnier area on the west side, a few more liters are being irrigated, simply to provide the required moisture depending on the location. So you see the calculation, exactly how many I can fit lawn sprinklers in a circle, how many Sprenger tolerates my system, which is not that difficult. You need this table. You need a rough idea of which sprinkler that is correct. You can see this in the throwing distances and in the water yields, or application rates that come out of it, such as different types. The rest is simple math, by just installing your sprinklers that you want. All the elements are added together and checks if they appropriately fit into the system. To find the right section here, meaning the individual columns, what do you need? You need the water pressure. You read it, simply with a manometer. Alternatively, check at the house or at the water filter somewhere in the house, ideally near the transfer point. I need the flow rate. How many liters does your water supply deliver in a minute, or per hour? You can read both of these in the table. You can also determine this quite easily. You need a bucket and a stopwatch. I showed you that earlier. It's not witchcraft. And ultimately, you need nothing more than this table. Once here with the green nozzles and black nozzles or the blue and gray nozzles, you simply read off. What distances do I want to irrigate? Then you choose the appropriate one. Check the nozzle, so the color, and then look in the table. Pressure, throwing distance, how many liters do I need? However, it may be that the water pressure or the water flow rate is simply not sufficient for you. Or, the Hunter i20, that's just too much of a good thing. I don't need that much at all. I need an alternative. Of course, there are alternatives. In this particular case, in my opinion, I personally believe it is the Hunter MP Rotator. I haven't installed it yet. This is also a sprinkler from Hunter. The Rotator produces a completely different throw pattern. There is also the MP 800 series. The throwing distance ranges from 1.8 meters to just under 5 meters. And there is the standard MP Rotator with a throw distance of 2.5 to nearly 11 meters. The difference from the i20 that I just showed you begins with the fact that here the nozzles undoubtedly indeed these Round circles are on top here, and you already have them in front of you. You need to buy the appropriate housing. With the i20, the housing is fully assembled with the nozzles. You can only change the small nozzle. There is only one housing, but in the Rotator series, there are different housings. For example, different heights for the riser, but also specifics like with the ProSpray PRS40. This housing mechanism automatically and effectively limits the pressure safely in various situations, ensuring optimal performance at all times. No matter how much pressure is applied, it is limited to 2.8 bar. I click on the standard MP Rotator button carefully. You see a completely different throwing pattern here. These are several jets. They run in a circle and then water your lawn piece by piece, your meadow or your planting, just as you wish. The water consumption is significantly lower. This is absolutely noticeable. However, it must run significantly longer to deliver the same amount of water. You can easily click through the website and take a look at everything. I am now clicking on the operating data from Hunter MP Rotator. Here I will show you how the calculation works with the MP Rotator. Here you can see, as you can clearly observe, the name of the housing once more. Again, the ProSpray PRS40. The housing automatically regulates the pressure to 2.8 bar. Furthermore, there are a total of 4 nozzles. These are the discs on top. There is the MP1000. It is suitable for throw distances of 2.5 to 4.5 meters. In addition, the MP2000 has throw distances of 4 to 6.4 meters. MP3000 ranges from 6.7 to 9.1 meters. The 3500 series goes up to nearly 11 meters approximately. That is definitely a big difference. You have nozzles here that already strongly determine the throwing distance from the outset. Another difference is that, unlike the Hunter i20, in this case, it is important to note that you do not have a freely and easily selectable spray angle. The i20 can be freely adjusted from a 50-degree throw angle up to 360 degree. The MP rotors have a nozzle in the 2000 variant that achieves a maximum of 90 degree. You have a nozzle that can achieve a maximum of 180 degree. There is a nozzle with 210 degree, 270 degree, and a nozzle that creates a circle with 360 degree. This essentially means that overall, the MP Rotator has a different spray pattern and throw distance. The nozzles are initially predetermined from the outset. You need to pay attention when you buy these Hunter MP Rotators and the nozzles. Can't you just say, I have 5 sprinklers, so I'll buy 5 black nozzles? No, you need to look closely at the front. This sprinkler is going into a corner and is supposed to spray at 90 degree. So I need a piece of this variant MP 2090 degree. I have a second sprinkler. It is located at an outer edge. It is supposed to spray around the corner. Then I need the MP 2000 with 270 degree. So you need to ensure that you order the right nozzles in the correct quantity. These nozzles are relatively inexpensive. If I were to currently substitute the i20 at my corner with a 90-degree angle now, I might do that, so my goal is to use the Rotator for the first time this year on a smaller scale. If I need to accommodate a lawn area, then I will buy the ProSpray PRS40 housing. This automatically limits my 4 bar of pressure in the waterline to 2.8 bar. A throwing distance of 4 to 6.4 meters would be sufficient. The MP Rotator 2000 with a range of 4 to 6.4 meters and 90 degree would be what I need to buy. The throwing distance of 6.1 meters is suitable in this case. With the MP Rotator, 25% of the throw distance can be reduced at the sprinkler. Otherwise, you don't have that many adjustment options. And then comes, here's something exciting. You see the flow rate is 1.6 liters per minute. Do you remember? Let me click back. The flow rate with the i20 using the black nozzle? At 4 bar, it was 8.2 liters. For the i20, it is 8.2 liters. While for the Rotator, it is only 1.6 liters. That's quite a significant difference. If your pump doesn't have that much power, does not provide enough, or house connection is small, or you simply need more sprinklers. If you want to incorporate them into a system, then these MP Rotators are really a great thing. I hope I was able to give you a rough, thorough, and comprehensive overview. How you, as amateurs, as beginners, can easily navigate. You can read into this system. How you can plan an irrigation system yourself. The alternative? The MP Rotator or the Hunter i20. That's the one I use. This is the one you have already seen in my videos. I am satisfied. I would do it that way again. I can give my full recommendation. I will try out the Rotator this year. Let's see, maybe. He excited me even more. Otherwise, regarding the installation, how it all goes into the ground. Just take a look at the description below. I have provided the corresponding playlist. If you want to know how it continues and stay updated, subscribe to my channel. Give me a like, please. I would be very happy. I am done for today and I say thank you. Until next time. Again.